There are two ways to show that triangles are similar. So let's say I've got some triangles like this. If I could show that for each of the sides I'm multiplying by a constant scale factor. So let's say, okay, let's go with 3, 4, 5, and then 8, 6, 10. Because I can see that I'm multiplying each of these by 2, I can say that they're definitely similar. One way of doing that, but the best way of doing that is to do 10 divided by 5 is 2, 8 divided by 4 is 2, 6 divided by 3 is 2, just like given that as a sort of an answer. So that's one way to do it. The second way is to show that all the angles are the same. Like what I mean is they correspond. So this angle here is the same as this one, and this angle here is the same as this one. Because then you're showing again, it's just potentially an enlargement of one to the other one. So I think I'm going to go the sides route, but I will talk about the angles route as well. Like at some point, you're definitely going to have to find this side here. How are we going to do that? Well, we can use Pythagoras' theorem because we've got a right angle triangle. It's going to be 4 squared plus 8 squared, square rooted, which is 16 plus 64, square rooted. So this is going to be root 80. And if I wanted this one, then it's going to be 10 squared minus root 80 squared, square rooted, which is going to be 100 minus 80 square rooted, which is going to be the square root of 20. So this is the square root of 20. So I now need to just match them up. Which one goes with which? Well, the two hypotenuses are going to go together, so that I'm going to relate those. But what other ones am I going to relate? Well, I can see that 4 is the shortest side here, and root 20 is going to be the shortest side here, so I would compare those two. And then I'm left with comparing 8 with root 80 again, because it's sort of this shared side. So let's do this carefully. What would we do to go from the smaller one to the larger one? What would we multiply by? Well, we would multiply by 10 divided by root 80, because I would then multiply that by root 80 to get back to 10. So I'm dividing them. I'm like doing 10 divided by 5 essentially, which would give me 2, and that would be the scale factor. So the larger side divided by the smaller side, but they have to be corresponding sides. So we said that 4 and root 20 went together, so root 20 is the larger one. And then it's going to be root 80 is the larger one on it, and then we're going to be comparing that with 8. So let's see if these are equal. We can do that. We can do 10 divided by root 80. That's root 5 over 2. Root 20 divided by 4. Root 5 over 2. And root 80 divided by 8, which is root 5 over 2. So I can say that they are equal to one another. Equals root 5 over 2. I might just add there's a common ratio. Or scale factor. Therefore, triangle PQS is similar to triangle QRS. That's enough. Now, just very quickly, how would I do it with the angles? Well, I can see that these two angles are equal, and to work out the other ones, I would need to do some trigonometry. I could work out this one by using tan, for example. I could work out this one. Once I've got some of the sides, I could work out this one using tan again, actually, or if I found the root 80, I could use that. I'd then have to find these other sides. I've done this essentially, only this point did I need a calculator for. I know it's a calculator question, but I think the sides here is a little bit easier. But you could work out all the angles using trigonometry and then show that they correspond, and that would be a conclusion after that. So just a second way of doing it if you prefer.